Breitbart Freedom Center here at the Heartland Institute in Arlington Heights, Illinois. As I think everyone knows, the Heartland Institute is a national nonprofit research and education organization. We've been around for 33 years. Yeah. Mike in the front row here is going to lead the applause, so if you see him applaud, you just go ahead and follow his lead. Yeah, 33 years, which is kind of amazing. We moved out here to Arlington Heights 2 years ago. We absolutely love it. We've got a huge library right around the corner and behind me. So if you can stick around after this meeting and check out the books, I think you'll be really interested and impressed by the collection that we've been able to put together. Our speaker tonight is Pat Michaels. Before I introduce him, I'm going to say a few things about a few things that have happened over the last few weeks, because it's been an amazing 100 days, if you like. The first thing is the election of Donald Trump as president. We had no right to expect that this guy would keep any campaign promises. I don't think we had any right to expect that he would be a thoroughgoing free market kind of advocate. And he's not that, but in a lot of areas it's remarkable. So this accidental president comes into office and he has done amazing things on the environment front in just his first 3 months in office. So his proposal to cut the EPA budget by 31% is tremendous and overdue and will have a major impact on the national debate. And probably zero impact on the environment, or maybe a small positive impact on the environment. So Donald Trump has transformed the debate on climate change, which we're going to be talking about today, as well as a whole bunch of other topics. And it really is a kind of new time in America where a lot of the ideas that we've been talking about for 33 years are now being talked about in the White House and at the cabinet level. And our agenda is actually moving forward. It's a great time to be a free market advocate in America. The second thing is 3 weeks ago we held a conference on climate change in Washington, D.C. It was our 12th International Conference on Climate Change. We had about 300 people sign up, which was kind of amazing because we didn't send out a single print invitation. We didn't run a single ad, even online. The original plan was for it to be a small meeting in D.C. aimed at congressional staff and White House staff. And when we put out the announcement that it was taking place, 100 people signed up within the first week. And we only had room for 150, and we had 40 speakers. So we said, well, we got to work something out. So we kept increasing the space by moving around air walls, and we were able to accommodate 300 people, and that's what we ended up with when the conference took place. 40 speakers. We had 55 media representatives there, which was a record for a climate change conference. I think that had something to do with President Trump being in the White House. All of a sudden, the mainstream media, which has tried very hard to just block out any mention of global warming skepticism, is now suddenly interested in what we have to say, because we are politically relevant. So that was a nice development as well. It was a great conference. We had people from the Trump administration coming in and out of the conference, sitting in on sessions for hours on end. And shortly after that conference, the president released his executive order on climate and energy policy. And part of that executive order was withdrawing EPA's determination of the social cost of carbon. And that was the theme of our conference. And I don't think that was in his executive order before our conference took place. So, thank you, Mike. All right, so that was the conference. The other thing I wanted to mention is a little book that's causing a lot of controversy right now. Why Scientists Disagree About Global Warming. Now, some of you who have attended past events here are familiar with this book. We published it back in 2015 in time for COP21 in Paris. And it got no attention by the media. They carefully ignored it. Okay, that's fine. But we distributed 50,000 copies of it. There aren't too many nonfiction books that go to 50,000 people, but people loved it. Tea Party folks, grassroots activists, our friends, our donors, business people. So we ran out of 50,000 copies in 3 months. So I talked to some donors, And they said, well, if you were to do it in color, that would be nice. Add some color pictures to it. Add a DVD to it. And send it to 370,000 people. That's over $1 million project. And I said, we can do that. And we are right now in the middle of distributing 370,000 copies of this book. We're sending it to every science teacher in every K-12 school in the United States, and to every professor of physical science, all of the national and state elected officials, 45,000 CEOs, and other lists that we're keeping secret. And this has become a big issue for two reasons. First, the media learned about it. We told them. I mean, it's in the last newsletter. It says that we're distributing 300,000, but of course they ignored that. But then they think they had this secret plot by the Heartland Institute to infiltrate K-12 schools in the United States with propaganda, and that became their story. So I would be interviewed by PBS, New York Times, Washington Post, I mean, all these major media outlets that had so carefully denied our existence, our very existence, are now interviewing me saying, how many copies, when are you mailing them, who are you mailing them to, why are you doing this, when did you first decide to do this, was it before Trump was elected, or was it after, who's funding this project, all these questions, none of them about the book. What does the book say? And when I would say, well, you haven't read the book, I mean, the book is about what you're asking about, that there is no consensus on global warming. I mean, that's the whole book makes that point. Goes through all the surveys, all the abstract counting exercises, all the science that's out there, and concludes that there's simply no consensus. It's a really wicked, difficult problem. And scientists recognize that, and they're debating it. They're no more close to determining the impact of human carbon dioxide emissions on climate than they were 20, 30, 40 years ago when the research started. But none of the reporters understood that, cared about it, asked a question about it. It was all about our motives, our funding, and the possible impact that it would have. Now, teachers reacted to the mailing, at least some teachers, and they were furious. How dare you send unsolicited research and commentary to teachers? Nobody else does that. Is that even legal? Yeah, oh, yeah, right. It is legal, and it is part of our mission. We're trying to reach influentials. We're trying to reach people who are educating the next generation. And it's entirely within our right to print a book and send it to teachers. And any person in this room could rent the mailing list of all the science teachers in the United States and do their own mailing of something that takes a different point of view. But it's caused amazing stuff. If you Google this, you will discover outraged teachers or teachers pretending to be outraged, and left-wing activists pretending to be teachers pretending to be outraged. And it's a kind of fun thing to watch. So we're trying to respond to legitimate expressions of concern by teachers. We're hoping that this is a teachable moment for teachers where we can open their minds to a different point of view on global warming. So it's a lot of fun. All right. There is a literature table back there. Please, it's all free literature. Take whatever you would like. We have T-shirts around the corner here, $10, cheap T-shirts, and they're great. Ayn Rand and Milton Friedman and Frederick Hayek. If you don't need a T-shirt yourself, get one for your kid or your spouse or your cousin or your uncle or your dad. They'll get a real kick out of it. At the end of this presentation, there's going to be time for Q&A. So I hope that everybody keeps in mind some questions that you might want to ask Pat when he's finished with his presentation. All right, and at this point, if I can find it, I'd like to introduce our speaker for the evening, Patrick Michaels. Before there was Joe Bast, before there was the Heartland Institute, there was Pat Michaels. He was writing, he's older than I am, he was writing about global warming, back before I realized it was even an issue. The guy is an institution and a legend among climatologists. He was the past president of the American Association of State Climatologists. He was program chair for the Committee on Applied Climatology of the American Meteorological Society. For 30 years, he was a research professor at the University of Virginia. He was one of the contributing authors of and a reviewer of the United Nations IPCC reports. He is currently the director of the Center for the Study of Science at the Cato Institute. He is the author of at least 6 books. How many? 8. 8 books now. The most recent one being Lukewarming, the new climate science that changes everything. He'll be signing copies of his book at the back at the end of this evening. Ladies and gentlemen, please welcome Pat Michaels.
Okay. Thank you for the kind words, Joe. You'll get your check in the mail very soon. Be made out to Heartland, though. Anyway, it's an honor to come here to talk about this book. This book took a long time to write. It really summarizes what I've been thinking for decades, and I was amazed at the way it came out. It looked horrible 3 months before it went to the editor. I thought, oh my God, this is going to get, you're going to get killed for sending this in, and somehow it all came together, and I really like it. I hope you will too. At any rate, this is the cover, and the idea is that Lukewarming is a synthesis of climate research, much of it fairly recent, that changes everything about the issue of climate change. Oftentimes, the issue is highly polarized into there's no such thing, there's no greenhouse effect from CO2, or the world's coming to an end, and it seems like there's nothing in between, which, of course, is the way that Washington works. Either the world's going to come to an end, or the problem that you're addressing simply does not exist, and thus does knowledge progress in our nation's capital. So let me just give you a little bit of what lukewarming implies. Whoop, there we go. Okay, the planet's surface is warmer than it was 100 years ago. It's about 1 degree C warmer than it was, let's say, around 1900 or so, 115 years ago. There is some component in the warming that has a human touch on it since 1976, but that's not really the point. When we look at the temperature histories, we'll see there's an awful lot of unexplained warming that has to be due to something other than human influence, and as a result, the natural variability of climate is pretty substantial. There's a warming from 1910 to 1945 that is the same magnitude as the warming from 1976 through 1998, whereupon the warming either paused or slowed down dramatically, and that couldn't have been caused by carbon dioxide, because if it were, the temperature would be so sensitive to CO2, we wouldn't be debating anything. We'd be heading for the hills, trying to get away from the sea level rise. And in lukewarming, or in greenhouse warming, there is a difficult prediction. You know, the historian of science, Karl Popper, wrote that science is really science when it makes a difficult prediction and the prediction turns out to be right. By the way, Popper also put forth the notion of what he called pseudoscience, which are so-called scientific explanations that explain everything and therefore cannot be tested. And his 2 examples of pseudoscience were communism and psychoanalysis. I would think that after you hear certain aspects of this talk, you may conclude that we're not even doing climate science, really. It doesn't merit the word science. But there's a difficult prediction made by greenhouse theory, and that is that the stratosphere, beginning about 50,000 feet above our heads, will cool at the same time that the lower atmosphere warms. Now, if somebody says, well, no, it's all the sun that's causing climate change, I'll tell you what would happen. The stratosphere would warm because there would be more energy coming into the Earth atmosphere system. And so the whole shebang would warm up. But you'd put CO2 in the air, you don't change the amount of energy coming from the sun. You take the warming radiation from the surface of the Earth, and the CO2 molecule is shaped like this, and it vibrates with a photon of infrared radiation. And then when it unvibrates, it's called an excited state. When it gets in its unexcited state, it releases that photon, and that photon will either go back out to space, where it would have gone if the CO2 was not there, or it's going to go back down and create an additional warming, an increment of warming in the lower atmosphere. And now we've reduced the flux of warming radiation in the stratosphere. And so the stratosphere should cool when the surface warms. But it's all a matter of degree, ha ha ha, as we will see. Now, this is the illustration number 1 from the book Lukewarming. This, to me, is the killer illustration of them all. It was done by John Christie initially for congressional testimony in 2015. All my illustrations here in this talk are updated with the latest data, so this goes through 2016. And you can see, by the way, this is the average of all 102 of the United Nations climate models in its most recent compendium, which was published in 2013-14. They're working on another one, and I think it's going to say the same stuff, because they all say the same stuff. These are, the circles are 4 weather balloon data sets that we have. There are 4 that are generally referenced, and Christie averaged them up. And the squares are 3 analyses of the same satellite data, the microwave sounding satellite that Christie received a special award from the American Meteorological Society for developing this record. Actually, I'm sorry, it was Roy Spencer. So, this is what's forecast. By the way, why does it do so well here? Because these models are tuned with the past. This is the volcano El Chichon. This is the volcano Mount Pinatubo. And if you get into the science, and we should talk about it in the Q&A, it has now been revealed that every one of these models is tuned, unrealistically, in order to make them simulate the climate of the 20th century. And any graduate student knows when you start tuning your model to make it fit the past, you're going to make it unstable in the future. So they aren't very reliable for the future. At any rate, this here, by the way, this is the 2015-2016 El Nino. And what's going to happen with that? Well, we'll see in a second. Now, here is the stratospheric temperature, the same time that the satellite records were taken, beginning in 1979. It's the same chart that you saw before. And here's something very interesting. By the way, volcanoes warm the stratosphere because they put black stuff in the stratosphere. Anyway, so the temperature declines fairly rapidly in the lower stratosphere, as measured by the satellite, till about 1995, 1998, and then the stratospheric temperature stopped dropping. Well, what happened to the surface temperature in 1995, 1998-ish? There's strong evidence that that stopped rising. So this is further proof that this is a greenhouse effect rather than a solar effect. You can see it maybe is coming down a little bit right now. Yeah, okay, and here's the surface temperature record from the University of East Anglia. This one is one that probably is the most trustworthy, which means take it with a grain of salt, not a bushel basket full. There you can see the big El Nino, 2015, 2016. We are going to hear less and less global warming stories over time because here is that same record showing monthly data, and you can see that the temperatures are coming back down to where they were prior to the beginning of the pause in 1998. Now, because of the way statistics work, if you run the trend line through this, it's going to show significant warming for a couple of years. But if this goes back down to here and stays there for about 3 years, well, there's going to be a lot of tall explaining that's going to have to be done. And I assure you, it will be what my scandalously young wife calls mansplaining. Okay, now, there are some places where these models might say that they're doing well. We could go to the Niskanen Center in Washington, D.C. They're all for a carbon tax. I'm not. And they have this chart where they show that the computer models actually work. That's why we need a carbon tax. And they show you the red line here, which is the Berkeley surface temperature record and the CMIP-5. Those are the models there. And this is for land only. Land only. Land only. Well, gee, if you saw the disparity in the first chart between the models and the globe in the lower atmosphere, and the land-only data has some sort of match, although notice that it tends to be below what's been predicted, man, you must really be doing horrible over the ocean. And that's 70% of the planet. You know, it reminds me of the old AMC Gremlin commercials. I would go to the Niskanen Center and say, you got 30% of the planet. Remember the Gremlin commercials? AMC Gremlin, where's the rest of your car toots? And here's the satellite record. This begins in 1979. and you can see it too is on its way down. And the satellite record before this big El Nino, the satellite record went all the way back to 1994 with no trend in it, while the CO2 was going up with reckless abandon. That's mind-boggling. It doesn't say there's no such thing as a greenhouse effect, but it says the natural variability is so high that it can overcome it for 1994, 04, 14, 21, 22 years and running. There's no computer model on the planet, aside from one, and it's the Russian one, that matches the current temperature trend. So something is very wrong in the vertical, obviously in the atmosphere. I mean, if you're getting, if you have the surface, some match with the surface record over 30% of the planet, but the models are just so far off when compared over the vertical, there have to be a huge error. And I want to show it to you, and I want to show you why it's important. This is another image from John Christie. He did this at his congressional testimony a couple of weeks ago. Now, this is a complicated image. Okay, I'm going to try not to bore you. I'm going to try continuing to look in this direction at the camera. But here it is. The red trace here, this is altitude. This is the surface, and it goes up here to about 50,000 feet or so. Each one of these is a level in the atmosphere. This is about 18,000, 16,000 feet. This is about 5,000 feet, and you're going up. And this is the average change in temperature per decade predicted by the 102 computer models. So at the surface, it's a little around 0.2 of a degree per decade. This is in the tropics. At about 35,000 feet, it is 45 hundredths of a degree, almost a half a degree per decade is predicted on average by these models. And then when you get further up, this is the stratospheric cooling. The computer models haven't quite got the stratospheric cooling either. And by the way, these errors here are quite phenomenal. This is this one here predicts an average warming. This is at about 40,000 feet of 0.35 degrees per decade. And what do you get? An average warming of 0. My God, I can't even tell you how many times that's off because 0 makes it undefined. It's really big, okay? And so now what does this mean? Well, this is in the tropics. This thing is called the tropical hotspot. And it's characteristic of the computer models. We can't find it. This is the tropical, just as warm as the surface spot in the real world. The green line is the real world. So it's not there. Now, you guys know, because you care about the weather here, because you have real weather in Chicago, you guys know that the vertical distribution of temperature is what determines atmospheric stability. And so when it's warm at the surface and cold aloft, the surface air is buoyant, and up pops a big old thunderstorm. And if you spin it with wind shear in the middle of it, out comes a tornado. So you guys kind of watch that sort of stuff. Well, in the tropics here, there's not a jet stream to stir tornadoes, so it's largely the vertical distribution of temperature. And what this is saying is the vertical distribution should be cooling off less with height, which would make the surface air more stable, which would reduce rainfall in the tropics on the average. What this says is happening is nothing whatsoever. Now that's the difference between maintaining a tropical rainforest with the current regime and probably drying it out and turning it either into a savanna or a scrubland. This is a huge error that these models are making, and nobody talks about it. Oh, by the way, what happens when it rains? The sun hits a wet surface, and the temperature doesn't go up because its energy is directed towards the evaporation of water. So, the average high temperature in Manaus, in the middle of the tropical rainforest, 3 degrees from the equator, is 89 degrees in the hottest month of the year, 89F. Think about what it is in the hottest month of the year where it's dry, like Death Valley. It's a bit warmer than that. So that makes the forecast of daily temperature off. And then the daily temperature forecasts are summed in the time steps in the computer, and that generates the precipitation forecast. This is whole cloth, ladies and gentlemen. I can say no more. I can't say anything kind about this, and to not recognize this is a travesty. Okay, so in the book, I talk about the national assessments of science that are mandated by law, the U.S. Global Change Act, I believe, of 1992. And what they are the U.S. Global Change Research Program, which is the entity that disperses climate research money to all agencies and all this good stuff. It's their view of the state of climate science. Now, I can tell you, in general, what they're going to say is it's a really, the world is in a very, very bad situation. And why is that? Because they're looking at a scientific literature that's somewhat biased. You see, if you pay everybody because global warming is a problem, global warming will remain a problem, and anybody who sends a manuscript in that says it's not is going to really upset the peer reviewers. You know why? Because that's a threat. If I saw that manuscript, I'd go, oh my God, I'm going to have to fly and coach again. No, this is wrong, this is wrong, this is wrong. And if you send in a manuscript that says the world's coming to an end, global warming is going to kill 3 billion people or something like that, oh, easy review. Oh, call up the televisions, they'll put it in Nature. They'll publish it as flashy science. That's what they do these days. And so what happens is you get a polluted canon of knowledge. You get a canon of knowledge that is effectively shifting in one direction. My next book, which I'm working on, is addressing this, and the tentative title, and it probably will change, the tentative title is High-Tech Larceny, How the Government Uses, quote, science, end quote, to take away your stuff. And I think you get the idea. Okay, so let's take a look at the first assessment of climate change. And this came out in 2000, end of the Clinton-Gore administration. And it was based upon two climate models. One was the UK climate model, which produced the largest precipitation changes of all the models they looked at in the 21st century. And the other one was the Canadian climate model, which produced the largest changes in temperature over the United States of all the models that they looked at in the 21st century. I kind of called them out on that, and they said, well, we wanted to see what the worst case scenario would be like. So you search through the article for worst case scenario. It never shows up. Anyway, so I decided to see how well these worked. And I looked at a very, very simple test of the models. Could they simulate the 10-year running mean behavior of surface temperature in the United States? After all, that's what they were being asked to do in the future. Could they do it over the last 100 years? Now, here comes a little bit of nerd science, okay? When you apply a model to something, you're supposed to explain a portion of it. So whatever is left over that you didn't explain will be less than the noise in the data when you started out. I thought, wow, that's strange. Let's see how much this is called reducing the variance. And I said, oh my God, the variance is larger after you apply the model. This is equivalent, and I'm not making this up, this is equivalent to taking a multiple choice test with 4 answers and getting less than 25% right. You actually added noise to the system. And it was not just for one model, it was for both of them. And so I wrote this up in my review of this. And I sent a copy to the head scientist on the assessment team by the name of Tom Carl, who was the head of the National Climatic Data Center. And I said, Tom, you can't go forward with this. This is malpractice. This is like prescribing a drug that harms the patient. I hate to tell you. It's exactly like that. And Tom wrote back, and he was very candid. And he said, we ran the test that you did. And we also ran it for other time periods than you did, for 1 year, 5 year, 10 year, 15 year. And I want to show you, I graphed up the result that he sent me. Come on. There we go. There we go. Okay. The red line is the variation in the observed temperature data. The blue line is the variation in the data after the model was applied to it. Dark blue is the Brit model, light blue is the Canadian model, and you can see at every time interval, 1 year, 5 year, 10 year, 20 year, 25-year average, the model added noise to the data. It was worse than a multiple choice test with 4 answers and getting less than 25%. And they still went forward. Now, it is my personal opinion that the Trump administration needs to know about this. And then we have the second national assessment, came out in 2009. I reviewed that and I said, I have never seen a document that was so incomplete. Virtually every paragraph is missing critical information. And so finally, Ed Crane and some of the Catos came up and said, that's pretty strong, Michaels. And I said, okay, you want me to prove it? And I said, I think I can produce a document that will touch every area that they touch, in the order that they touch it, and that it will show exactly what I just said. And he said, well, how much is that going to cost? I said, about $350,000. He said, okay, go raise the money. So we had a fundraiser, and after 20 minutes at the first cocktail hour, I had it. Okay? So here was the original report on the left. It says, there's global climate change impacts in the United States from the U.S. Global Change Research Program. And the first thing you notice is this is about global climate change impacts in the United States. So what's this chart down here? That's not U.S. temperature. That's their global temperature record. And by the way, last I heard, an important component of climate was clouds. Clouds reflect away solar radiation. You know, it's cooler in the shade than it is in the sun. So we actually did this one here called the addendum with pretty much the same cover, except we put the U.S. temperatures in here, which strangely enough weren't doing anything. I wonder how that happened. And we even put some clouds in our climate. And so the publications matched. Okay, let's go forward. Can you hit this? Give me a slide. Okay. The publications matched page for page, literally. They had their key findings in their second assessment report. Let me see if I'm going to step away a little bit here. I want to be able to read one of these. Let's see. Crop and livestock production will be increasingly challenged. Many crops show positive, blah, blah, blah. But anyway, it's going to be bad, and there are going to be pests, poor adaptation changes for crops and other production. Point number 5, crop and livestock production will adapt to climate change. There's a large body of evidence that demonstrates substantial adaptability of U.S. agriculture to climate change. Okay? Risks to human health will increase. Life expectancy and wealth are likely to increase. And for each one of these things, like we did, we listed the pages in our report where we surveyed, where we looked at the scientific literature that supported that conclusion. And we were able to do that. They had 500 citations. I managed to find 900. And then they did things like this. And I want to show you. If you thought the last one was bad, where it did worse than a table of random numbers, well, this one's even worse. This is a graph that's designed to make you feel real queasy in their report. What it says is this is the growth rate for corn during reproductive response, in other words, when it's tasseling and flowering, and this is vegetative growth. Like teenagers and young adults, plants are more sensitive in their reproductive phase. And same for soybeans. And you can see that as the temperature goes up, well, the optimum is reached, and then the productivity starts to decline, and we'll go negative at corn at about 95 degrees and soybeans about 102 degrees, assuming no adaptation, of course. And so that's the take-home lesson from this. In fact, outside of this range, the plant will not reproduce. This is scary. It's also wrong. This is from Craig Idso. Craig is a person who has done a lot of work here with Heartland. This is for aspen trees. This is the optimum temperature for photosynthesis at pretty much background CO2 concentration at 325 parts per million. The optimum leaf temperature is about 50 degrees Celsius. This is net photosynthesis here. So if you shift the carbon dioxide up to 2,000 parts per million, what happens? The optimum temperature goes up. Gee, I wonder why. Maybe because pretty much every plant that we live with and depend upon, either for food directly or we pass it through a protein machine, every one of those evolved in an atmosphere with more CO2 in it on a warmer planet. And so when you put more CO2 around the plant, its biochemistry adjusts and the temperature optimum for photosynthesis goes up. I'm completely shocked. You know, there was a guy at the National Academy, he's still alive, Paul Wagner. God, he's old. If I can say that, that's something. But Wagner said, you know, he ran the Connecticut Agriculture Experiment Station. He said, You global warmers are all ascribing to the dumb farmer syndrome. You think they're so stupid that they won't adapt. Or you think plants don't have adaptive mechanisms in them. Well, of course they do. This is plant growth enhancement from elevated CO2, percent growth enhancement, atmospheric CO2 enrichment. This is a summary of about 2,000 scientific papers. Because of the influence of two scientists, Paul Wagner and Sylvan Witwer, they were older and they got into the game before the CO2 craze. And they decided the CO2, they said CO2 is making things grow better, it's obvious. And so they had this tremendous number of graduate students who had this tremendous number of graduate students. And that's why when you look at the agriculture literature, you don't see the gloom and doom. You see, well, yeah, it looks like it might make things grow better. Whoops. Okay, here's U.S. corn yield from 1930 to 2016. You can see how that's been horribly affected by climate change, et cetera. The fact of the matter is, for reasons unknown, and I did a PhD thesis on this, in agriculture, once a technological trend is established, it goes on as a straight line. I've asked many mathematicians, I've given them my theories as to why that would be true. Can't prove it, but it's an ubiquitous phenomenon. That's corn yield. Production is the yield times the number of acres planted, okay, as opposed to that. And that's going to be this slide right here. This is global crop production from 1980 through 2014. A paper in Science, this was in response to a paper in Science magazine that said global warming is reducing crop yields by X%. And I said, really? Or no, it said crop production, I'm sorry, by X%. I said, really? How about you take a look at the numbers? Because they are there. The increase is a low order exponent. The increase has been very stable in that low order exponent for God knows how long. This is a result of increasing yields and increasing acreage. Yield production is the yield times the number of acres planted. No, okay. Aha! But it's not just agriculture. This is, through 2009, this is the greening of our planet. Now I want you to be careful of the color scales here. So follow me if you could. Pink is, this is the amount of leaf area on the planet. These are huge increases, 29, 10 to the minus 2 meter squared minus meter squared per year, or whatever it is. One of those units, okay? And you'll see that here, this is the tropical rainforest. This is the southern part of the this is the tropical rainforest in Africa. Dense forest here, tropical forest here. They're getting greener and greener and lusher and more lush. There's nothing being done to these things. People aren't putting fertilizer on them. The only fertilizer they're getting is carbon dioxide. Now, look on the map and try and find me an orange spot. Well, I found one there in northern Argentina, maybe one there. Things are maybe not as green as they were in Australia, except where the dots are on the map, it's statistically significant, so it didn't even get out of the noise in Australia. So where it's significant, it's getting greener everywhere that it's significant. Now, we have another third assessment report that came out in 2014, and the Obama administration used it as the excuse for its Clean Power Plan repeatedly. I would like to say, when the National Oceanic and Atmospheric Administration proudly released the third National Climate Assessment on May 6, 2014, the agency was pleased to note, and I'm quoting from a NOAA press release, the report, a key deliverable of President Obama's climate action plan, is the most comprehensive and authoritative scientific report ever generated about climate change that are happening now in the United States. Wow. Hurricanes are increasing in this report. Here, I'll show it to you. This is the hurricane intensity according to, sorry, got there. Darn, did I skip over an image? Wait a minute. I'm sorry. Back. Yeah, that's it. Okay, this is the most comprehensive report ever published on climate change impacts in the United States. This is hurricane trends, hurricane power in the Atlantic Basin. This is from the report. This is the Atlantic Basin. You can see it going up from 1980 through 2010. Well, there's another scientist, Ryan Maui, who tracks hurricane intensity around the planet, and he has what's called the Accumulated Cyclone Energy Index, and maybe you'd like to see what it looks like. Yep, sorry, there we go. Okay, here we are now. These slides are updated through April 1st, 2017. If you see any trend in this whatsoever, this is global accumulated cyclone energy. This is northern hemisphere accumulated cyclone energy, and so the difference between the two is the southern hemisphere, and there's no relationship whatsoever with surface temperature. There's no trend whatsoever. So what did, I got to read that sentence again. What did the most comprehensive and authoritative scientific report ever generated about climate change, what did they say? How did they get this result? Well, turns out that power dissipation index, it can be calculated all the way back to 1900, because we know where the strong hurricanes are. You don't miss a Category 3 hurricane, or you don't miss very many of them. And here is what they did. There we go. So they talked about the big change from 1980 to 2009. Well, let's see. That's this period right here. The report was published in 2014. What happened to these years? Oh, they must have been inconvenient facts. Or these years here, extremely inconvenient. That's the most comprehensive report that's ever been done on United States climate. And you can read all about it in the book Lukewarming. Yes, and of course tornadoes and severe storms are going up. This is the annual number of tornadoes, F3, 4, and 5. I knew Fujita when I was at University of Chicago. God, he was a funny guy. I think he was a fighter pilot in Japan. And I've heard stories that he'd fly around looking at thunderstorms in I think one of the NASA jets or something like that, and he'd insist on flying the thing, terrifying everybody on board. That story may be apocryphal, but I was told it. Anyway, the reason I bring that up is the actual number of tornadoes is going up. And the reason is because we have better detection equipment. You know, the whole tornado thing started in 1950. When was the Worcester tornado? 1954? And it was a huge tornado in an odd place in Worcester, Massachusetts, and then one in Flint, Michigan about a month later. They killed scads of people, one in Waco, Texas the same summer. And David Atlas from the University of Chicago went and said, look, we got this radar thingy, okay? And we can detect these things. And so they put a network of regular planned position indicator radars around the country. And lo and behold, the number of detected tornadoes jumped. Shocking! And then we got the new Doppler radar, WSD 88 for 1988. The original one was WSR 57 for 1957. And guess what? The number of tornadoes went up again. Shocking. But these are little twisty things that may knock over a trailer if they're strong. They seem to have an affinity for trailer parks. No one knows why this is. But nobody misses a Category 3, 4, or 5 tornado with the population density that we have in the United States. You're not going to miss that. And if anything, they're actually going down in their numbers. A tornado death frequency in the United States, this is called adaptation. Okay? This is what people do to the vagaries of weather and climate. This is the adaptation of a society to tornadoes and the ability to detect them. I'm almost done. Don't worry. And by the way, remember that paper that was submitted to Nature that said 3 billion people will die from global warming? That's kind of apocryphal. I think it was 1 billion. But the fact of the matter is you get the same thing on global warming related deaths. We published this paper 2004 where it shows that the more frequent heat waves become in American cities, the fewer people die. Shocking. And I did that paper with Bob Davis at UVA, and I remember talking to him and saying, Bob, why are we doing this? We're writing a paper that says people don't want to die. They're not going to accept this. And he comes into my office a year later and said, yeah, you know that paper we were talking about? It won Climate Paper of the Year from the Association of American Geographers. I said, that tells me everything I want to know about my profession. That they give an award to a paper that says people don't want to die. I just discovered this. Here are the, this is again, a criticism of the third assessment, impact of billion-dollar weather disasters. Everybody says weather-related damages are going up. This is the government's own data, for God's sakes. No, they're not. Thank you very much. And that's in percent of GDP. That's probably a good way to do it. or you could adjust the raw numbers for population and real estate values. If you want to do that, you'll get the same answer. Whoa. So we're gonna finish this talk by telling you what's really going to happen and give you a nice enlightening send-off, okay? This is what is the basis for the social cost of carbon calculated by our government. These are old models, and it used a distribution of global warming, a frequency distribution, which peaked at about 2.8 degrees climate sensitivity and had this huge long tail out here. This is the source of the insurance policy. Well, there's a finite chance, the insurance policy argument, there's a finite chance, we could have a really disastrous warming, therefore we must do this. Well, beginning in 2011, more and more papers started to appear, usually from people not, quote, mainstream, but very good papers, arguing that sensitivity is nowhere near as high as it was. Sensitivity is the amount of warming you get for doubling carbon dioxide. Like I'd say, it's not the heat, it's the sensitivity. It's warmer than it was, and it's going to warm up a little more, okay? But you don't care. You care about how sensitive it is, and that's what means something. So this is a probability density for warming now when you use realistic parameters for the amount of junk we're putting in the air, and it drops to about 1.3 degrees. And here is the massive literature since 2011, all these low sensitivity papers, and the government uses a sensitivity range that starts here and goes all the way out to there. It's just wrong. And the Trump executive order said, you got to use the right stuff, folks. There was no doubt that was in there. All right. So we're going to close, seeing as it's beginning to be summer, we're going to close with the colder places on Earth. This is a sea ice extent in the northern hemisphere until the satellite sensor broke about a year ago. So it's kind of hard. There are different sensor records, but there's a lot of apples and oranges going on right now. But you can see in the northern hemisphere, this is North Polar sea ice, going down, okay? And if I wanted to be like a person in Washington and would stand in front of the data I don't want you to see, or something like this, I could say, well, see, it's really not changing. It did go down, and it appears to have stabilized, but with more variance because the ice is thinner in the northern hemisphere. Fine. Southern hemisphere, different story, statistically significant increase in sea ice in the south. There was a real drop in southern hemisphere sea ice, by the way, that took place about 18 months ago. Massive drop, and then it's since come back. All the heat from the El Nino, that water got in that area down in the south, and it's come back fairly quickly. But this is what we're worried about. And if you want to stop somebody dead on this issue, say, but what happens if all the ice falls off of Greenland? After all, if it did, sea level would go up 20 feet or something like that. There's a lot of ice on Greenland, 10,000 feet high on the top. The reason it's there is because it's there. It's a relic of the Ice Age. It's so cold at 10,000 feet at that latitude that it stays as ice. But the fear is, as you know, Greenland melts every summer. You can go to Greenland. I have. It's very, very impressive. And there's meltwater all over that ice cap. And so the idea is, as it warms up, the meltwater gets underneath the ice cap, and it lubricates the ice flow, and it falls off of Greenland. Well, unfortunately, the reason that there are glaciers is because there's water underneath. That's how they flow. So this would take glaciers and turn them into glaciers. But the question is, the warming there, will it be unprecedented? And I can answer that for you with a very heartwarming story. It was much warmer at the beginning of the last interglacial, about 10,000 years ago, than it has been recently. It has to do probably with the orientation of the sun and the Earth orbit geometry. And so people have looked, and it looks, considering these different lines of evidence, a picture begins to evolve suggesting the Arctic sea ice cover was strongly reduced during most of the early Holocene, that's after the end of the Ice Age. There appears to even been periods of ice-free summers. In large part, oh my God, the sea ice was all gone in the Arctic Ocean. And the period of length is about 3,000 years. Recent mapping of a number of raised beach ridges on the north coast of Greenland suggests that the ice cover in the Arctic Ocean was greatly reduced some 6,000 to 7,000 years ago. The Arctic Ocean may have been periodically ice-free. Different different geologic survey. And so what happened is all the ice in the Arctic Ocean melted at the end of summer naturally for between 2 and 3 millennia after the end of the Ice Age. Now, may I point something out? It survived. It survived what we can do. But it gets better. Only 3 more images, Joe. Only 3 more images. Okay, I'll speak like Al Gore. Hi, I'm Al Gore.
Oh, thanks a lot. I really needed
Just
this
like
today.
you,
Okay,
only better.
okay, right.
And when I talk like this, I'm lying. Anyway, at the end of not the last ice age, but the one previous, if you're here in the United States, you call that the Illinois Ice Age, okay? Wisconsin, Illinois, et cetera. It's also Sangamon, also is another name for it. Anyway, at the end of that ice age, probably because of the sun, it was warm, really warm for 6,000 years. 6,000 years, centered about 118,000 years ago. And it was thought the summer temperature were maybe average 2 degrees C warmer than now in Greenland at that time. And then a woman by the name of Dahl Jensen and her research team drilled down into the ice and got to the bottom of the ice, and it was older than the Eemian. So they could look at the ice in the core, and they could estimate the temperature of when the precipitation formed, because the oxygen segregates into 2 isotopes, O16 and O18, dependent upon temperature. So they could infer the temperature in that 6,000 year period. And they can infer the altitude, the height of the ice, from another isotope of beryllium that has to do with the amount of solar radiation that's hitting you. And what they found was that it was 6 to 8 degrees C warmer than the 20th century for that period of 6,000 years. Let's just be conservative and put it at 6 degrees, because that's really what their chart looks like. The thickest ice is approximately 11,000 feet in depth. 6,000 years of the Eemian, the temperatures, the depth change, maybe 1,000 feet. Now, that's all that happened. So let's just do a little math to close this talk. Whoa. There we go. Okay? The Dahl Jensen Eemian ice core is 6 degrees C times 6,000 summers. That's 36,000 degree summers. Just like degree days that you calculate your heating need, well, these are the degree summers hitting the Greenland ice sheet for 6,000 years, 36,000 degree summers. Worst case from the climate models, 5 degrees C for 500 summers. Probably not true. Probably not true. That's 2,500 degree summers. So, along about the time this research was done, a woman by the name of Lindqvist from, I believe, the University of Washington in Seattle was doing some work in the Arctic and ran into some bones and said, hey, how old is this? And here's some mitochondrial DNA. Can you tell me what it was and how old it is? 126,000 years old. It was before the Eemian. It was from the penultimate ice age. Results came back. Come on. It was one of these. So it survived not only what we could do, but what nature could do for 6,000 years. The icon's got to go. It's going to survive. We need something new that's cute if you're going to be scaring people. But that's the good story. It's a lot more stable than you think it is. Thank you very much. Sorry about that.
Well done. Thank you very much, Pat. And I think coming up very soon is International Penguin Day, so maybe that could be another mascot.
When is that?
Tomorrow, next week.
I was going to wear a penguin tie tonight, and I discovered a food stain on it.
Okay.
Just saying.
It's Q&A time, and actually on the in the chat room on the YouTube page, it's been quite lively, as it tends to get on climate issues, and I'll be reading a few questions from there as well. But if you have a question for our guest tonight, please raise your hand. Somebody with a microphone will come over and hold it in front of your face so that you can be heard by everyone here and watching on the live stream. We're going to start right here with Jim Johnston.
Thank you very much. That I remember hearing a presentation you made years ago. I think you were wearing the same clothes. No, these are new. I got these for my birthday. Within the north. One of the points that you made, is still is what? That what warming did exist occurred in the depth of winter. Right. In large land masses. Yes, that's correct. Yeah. Yeah, I think that there's certainly good theoretical reasons to believe that's true. And, well, actually, no, I have to tell you something. Wait. I've checked that. In Siberia, it looks like it changed, that it was not as true now as it was when I published that paper. But I think in North America, it's surely the case, because the frequency of polar outbreaks, the things that take it down to minus 30 in Cut Bank, those have dropped dramatically. Yes.
Oh, you've got to be absolutely frustrated by some of these science models where the scientists have to ignore the empirical evidence in order to support what is considered a lie. My question is this: there must be empirical evidence that the Earth itself is the one that regulates itself, is there not?
I think it's kind of a Gaia kind of question. I'm agnostic on that. I really haven't thought enough about it to give you a thoughtful response, and so I probably shouldn't respond. Okay?
Question for the Heartland Institute and also you, Mr. Michaels. 2 weeks ago, I was at the local movie theater, and I see that Al Gore's got a new movie coming out, and I'm wondering if you're going to review the movie and point out possibly all the fallacies in his latest follow-up to Inconvenient Truth.
I don't have enough time.
Because I would assume the media is going to give him all the airtime he wants.
It's out. It's out now, isn't it?
I don't think so. No.
Oh, of course. You said the third week in July is climatologically the hottest week in the United States. That'll be when it will come out. I assure you.
Just a question on volcanic activity underneath the oceans, and is that immeasurable, and any effects on the ocean temperatures at all?
That's a theory that keeps bubbling up. Pardon the expression. And my answer to that is, well, gee, if you really look and see where the majority of the warming is, it tends to be in the cold air masses over the land areas. And if the warming were coming from there, you should be able to see it somehow moving from there to those regions. And you don't. So I just discount that. But I do hear that one fairly frequently. Yeah.
Good evening. My name is Mike. I'd like your take on a couple of things. One, on the Milankovitch cycles and their validity, in terms of long-term climate change, and also the Lake Vostok ice cores, where they graphed it out and said that actually CO2 followed warming, was not the cause of warming.
Well, I'll take the Milankovitch first. My general impression is Milankovitch works pretty well for the last two, for the Illinois and Wisconsin, or Wisconsin and Illinois, glaciations rather, and that there's not as precise a match in the early ones, which may be because we have bad ice data too. I don't know. Number two, that was again on the that one, yeah. Well, it's easy to explain that one within the paradigm of what I call, big global warming, and that is the following. This carbon dioxide solubility varies with the temperature of the fluid. That's why when you warm up a can of soda pop, the fizz goes out of it. And so imagine if there were for whatever reason, maybe a lot of volcanism or something like that, and the CO2 concentration in the atmosphere went up, that would warm presumably the ocean a little bit, and then that would release more CO2. And so you could interpret it, I've heard that interpreted differently as a feedback effect, could create a feedback effect. Of course, there's the simple interpretation of it, which is it seems to have cause and effect misplaced, but the feedback effect argument is very hard to defeat. I have not seen a refutation of it, although it certainly makes a lot of people uncomfortable that it looks like the chicken sometimes is before the egg. Okay?
Okay, I have a question here from online. Please, if you're in the room, please raise your hand and somebody will come next to you. This was concerning your slide on the greening of the earth.
Yes.
Pat. What impact does the forest industry have on the data that you have in that slide?
Oh, that's satellite data. That's remotely sensed. If the question is how much of that is because of commercial forestry, the answer is not very much. Certainly not in the tropical rainforest. That's not harvested commercially, and that's the huge increases in the tropical rainforest. They're just amazing on the satellite data.
This is a fairly simple question. Do you have a definitive number of what percent of greenhouse gases that CO2 constitutes? And then of the CO2, what percentage is anthropogenic versus natural?
Correct. I know the question. Of course, the most common greenhouse gas on the planet is water vapor. And if left to its own devices, the surface temperature would be raised, I think, 25 degrees C by the water vapor in the atmosphere. And CO2, I mean, obviously the volume of CO2 in the atmosphere is measured in parts per million, and water vapor is measured in percent. Okay, there's quite a difference between parts per million and a percent. That's parts per 100. So yeah, it's small. And the point about the anthropogenic contribution, the anthropogenic contribution is about 3% of the flux of CO2, in the total annual flux of CO2 in the atmosphere. Most of it comes from the respiration and decomposition of plant material. And that's why if you look at the CO2 closely, you see it goes up. It actually goes, there's an annual cycle to it related to that. Howsoever, it's assumed that those reservoirs were in equilibrium until we started taking fossil carbon dioxide, or carbon, and oxidizing it by burning it. And the evidence for that is that the C13-C12 ratio, that's carbon-13 to carbon-12, resembles old carbon as opposed to some recently fixed stuff. And it more resembles what you would get out of petroleum and coal than it does, say, from burning a log, which is new, if you will, CO2 fixed. So that's my answer. I think CO2 is going up, and this isotopic ratio indicates that it's mainly us. By the way, and this is one that really bothers me. Oftentimes you hear that a volcano puts out more CO2 than human beings. Well, I can tell you right now, if you look at the carbon dioxide history, the concentration in the atmosphere, since records began in, the modern record began at Mauna Loa in 1957, you have at least 3 big-time volcanoes. You have Mount Agung, and I think that was 1962. You have El Chichon in 1983 and Pinatubo in 1992. And there's no spike in the atmospheric CO2 record after any of those. And Agung was the biggest eruption since Katmai in 1912. So you just don't see it. I know you hear it all the time, but I'm a data guy, and I'd like to see it.
Let's go over here. Please identify yourself so Pat knows who.
Larry Greenberg. I have one moderately silly question and one policy question. The silly question is, in Tierra del Fuego, since the ice cap is increasing down there,
Yeah, it is.
Are they worried about this? That's the silly question. And the second question is,
Brings more tourists.
what is the policy prescription based on what you
Lukewarm?
have said? Yeah.
Oh, I'll answer the second one first. If the sensitivity is sufficiently low, the fact of the matter is that technological change occurs so fast that we probably are going to just have increasing pressures toward efficiency that aren't environmental. They're because people are cheap. And to say that we should prescribe the energy future of our country is based upon knowledge that is close to ignorance. And I will emphasize why I said that. If I went to a cocktail party in Washington, say in 2004, I would imagine, somewhere around 2004, maybe 2003, and the talk at the cocktail party would be, oh my God, the price of natural gas is high because we're running out. And it's just, I mean, we got some of it, but hey, that's all there is. And I said, well actually, we have several hundred years of it pretty much right beneath our feet, and it's around the world, and all you got to do is break rocks. You know how that would have been received? Oh, what an ignorant person. But that's what happens in energy. So the efficiencies there seem to be market pressures there. The reason natural gas has displaced coal for electrical generation has nothing to do with the environment and everything to do with the fact that it's cheaper. And the plants are cheaper. They're much more simple. You don't have to capture the dust and the sulfate and all that good stuff. So what I'm saying is, given a lower sensitivity scenario, doing nothing is actually doing something. It will promote. It will. Northern Illinois Gas. Whoever bought them? Anybody remember that company? They had a motto that I really love, and I use it all the time. Was the future belongs to the efficient, and that actually is true, and that's where we're headed. So, but there was another question though, right? Oh, Tierra del Fuego. Probably has to do with the fact the Southern Ocean has warmed a couple tenths of a degree. Not very much, but there's a lot of water down there, and Tierra del Fuego is going to support a glacier. And if you put more water in that atmosphere, just like we're finally beginning to see in Antarctica, as has been forecast for a long time, snowfall increase. The UN's models in the previous climate report had Antarctica growing over the course of the 21st century, precisely because of that. So.
Did we have a hand up over here earlier? I have a question if somebody wants to put their hand up and get next. But Pat, earlier today, you and I were on the podcast together, and we talked about, this week on Tuesday, Donald Trump had planned a high-level meeting with his cabinet members and his top advisors with the topic of whether or not he was going to keep his promise and pull out of the Paris Climate Treaty. As you and I talked about on the podcast, that's fraught with a little bit of maybe some trouble, and certainly takes more time than just simply withdrawing altogether from the United Nations conference or framework, convention on climate change, the UNFCCC. So, because that you can get out of pretty quickly, in about a year after turning in your paperwork. You could talk a little bit about that, but I just want to know, what do you think would happen to the world's global warming industry, the climate panic industry around the globe? What would happen to it if the United States just pulled out of the UNFCCC?
Well, it's funny you should ask that question. People used to say, I would always get this question, and I could get it tonight. Maybe you just asked it. Well, you're saying there are systematic problems with this particular science for reasons that were kind of obvious. So I would say, well, I suppose you will be surprised that if you do what Tony Abbott did in Australia when he was named prime minister when the Liberals won a few years back, he went to the people at CSIRO, the Commonwealth Science and Industrial Research Organization. It's their mega thing down there for science. And he said, oh, you guys, you say the science is settled. Okay, then there'll be no more money for climate modeling. Oh, did they howl. Oh, no, we didn't mean it. We didn't mean it. So my answer generally was, well, I suppose you could stop funding this stuff, and then, maybe people would be a little bit more candid. But that's really not that good an answer. The real answer is, if you withdrew from the Framework Convention, the entire machinery that has grown up to create the need for Framework Convention would no longer be there. That probably would do it, and I have to say that is not my original idea. That came from the guy who asked the question. So it's Jim Steele.
You know a setup when you see one, Pat. I appreciate that. Any other questions out in the audience? I have another one if nobody has their hand up. Pat, I wonder if you could talk a little bit about what the Cato Institute is doing on this topic of climate change. Cato Institute, based in Washington, D.C., very prestigious. There's a lot of people that have been involved in the transition team, for instance, and are close to the politicians, the policymakers out in Washington. What is Cato doing on this topic that people should know about?
Well, obviously we're doing a lot of research, books, testimony in front of Congress and things like that. And I think that as long as the misrepresentation continues and leads to policies like came out of the last administration, somebody's going to have to take them on. That's just the way it is. And this is the overarching environmental policy issue of our lives. And if you just say, well, because there's a different president right now, it's going to go away, it's not going to go away. I assure you, the institutional memory is there. The GS-15s who've been schlepping all these bucks around through the agencies, they're still there, okay? So it's not going to go away. And then the other thing that we're doing at Cato is this has led to a discussion of problems in science in general. And the fact of the matter is that it's not just climate science where we're seeing this. I can give you an example. Have any of you ever heard of a guy by the name of Edward Calabrese from University of Massachusetts? This guy's mind-boggling. His field is they're a little bit more open to new ideas. He's a toxicologist, and he's a really impressive guy. He wins the teaching award there all the time, and he discovered via looking at something else that the model that we use for the regulation of carcinogens and ionizing radiation, which is something called the linearity no-dose threshold model. The model holds that the first photon of ionizing radiation has the same potential to cause cancer as the bajillionth photon of ionizing radiation, and that it's cumulative. And the DNA destruction process is cumulative and blah, blah. Well, that's just not true, okay? Organisms that are in low levels of things that are harmful for them in high levels will take advantage of low levels. So, for example, solar radiation is ionizing radiation in the ultraviolet. You need that to synthesize vitamin D. If you don't have any of it, your bone growth will be highly abnormal. You'll get rickets, and it's horrible. As one of the characters in Outlander had a vitamin D deficiency in the story. Anyway, and so you need that, but at high volumes, obviously, sunburn being one thing, skin cancer being another. Sunlight is a typical example of what's called a biphasic dose response. And if you don't think it's real, I'm looking at this audience and I'm looking at myself, and I can tell you a lot of these people in this audience are on chronic medication for one condition or another. What you're taking is beneficial for that beta blocker that I take because I'm an old fart, and it's beneficial. And sure, I could take the whole bottle and maybe cause some really serious problems, including respiratory arrest. or trigger an asthma attack in a non-asthmatic person or something like that. So you live with that model. That is the therapeutic model. That many things in low doses are beneficial that are very harmful in high doses. Alcohol, typical example, and the alcohol heart disease thing, and obviously, and I don't need to tell you the rest of the story. So this is the way the world works, and we are regulating based not upon that, but upon a model that is so obviously wrong. And this is Ed Calabrese. This is one of the things that Cato is doing. He's a scholar with us on adjunct. We think that this is an example of science corruption writ large, and he has written a lot as to how this got established. It's a story very much like global warming, very, very much like it. And it should actually be a template. Had I known about it, 15 years ago, I would have said, this has happened before, because it did. So it's part of the human way. It has to do with big men, big theories, power, politics, and money. Shocking.
Terrific. Let's get, we have one last question here in the back.
It seems like you have some very compelling arguments, yet, the liberal progressive side, I read the Daily Herald, they say, well, yes, there was an argument, there were editorials saying they're addressing the fact that a lot of scientists were not, versed in climatic science. So they rule them out, and they say 97% of the scientists in the climatic area are now saying that there is human-based global warming.
So?
It seems like they're winning the battle, the propaganda battle. You
Well, wait a minute. I just said that.
There's an economic issue for people to create a scare, no doubt, but why are they winning the battle, it seems?
Well, the 97% figure should really be 100%, I think, because of the stratospheric cooling accompanying a slight warming. But the fact of the matter is that's never the point. The 97% argument doesn't say how much, and if it said how much with high confidence and that it was an extremely high value, that would be wrong. I would think that you can find a lot of skepticism, not necessarily expressed in public, but amongst friends or enemies or frenemies. There is, I think, some real suspicion of the high-end forecast, and there are devotees of the high-end forecast, and I just don't think they're justified. I'm going to be really interested to see what happens if that surface temperature and the satellite surface, lower tropospheric and surface records drop back to where they were prior to the El Nino, and that hangs on for a couple of years. Yeah.
Very quick.
Last question right here.
A very quick question. Are you allowed to speak at Berkeley?
I haven't been asked.
Okay. Well,
I'm sure that it would.
Safe.
I would love to speak to people that disagree with me because I know I mean, talk about a lefty place. I've been invited to Oberlin twice in the last few years, and there were people that were going to demonstrate and mill around, and then they come and hear the talk and go, "Holy, he's not crazy." This makes sense. So that's why anybody here can get me a gig at where would I want to go? Wisconsin's actually pretty good in these areas. I mean, they gave me a PhD, so they got to be great. So
That just shows they're smart.
yeah. Anyway, so no, I love to do that, and that's my answer. Do you want to? You should let him ask the one last question. He had his hand up. No, right there. You.
Oh, me. What do you think is going to happen to the climate? Do you have any predictions of where you think the climate's going to go?
I think that there will be a net warming between now and the end of the 21st century. Let's see, where are we right now? Probably 0.6 to 3/4 of a degree C, and that's And by the way, did I mention that the United Nations, when there's this 2-degree goal, the people who put that together, honest to God, include the warming of the early 20th century as a greenhouse warming, CO2 warming. That's complete nonsense. That couldn't have had anything to do with it. That's how that figure is calculated. And, what can I say? Well, if the sensitivity is low, we're not going to get to 2 degrees by 2100. And, we can't go planning people's lives for putative events 125 years from now. There's something that is always absent in this so-called debate, the words opportunity cost. And believe me, there's a huge opportunity cost for doing that. Okay, thanks.
All right, let's
Jim.
give our speaker a round of applause, please. Thank you, Dr. Michaels. You can stay there for a moment. You can still get copies of his book on the table on the way out. There's also something called the Dip Jar. So if you'd like to donate to the Heartland Institute in a secure, quick way with your credit card, you can do so right there on your way out. On a week from tonight, next Wednesday, Dan Pila, one of the policy advisors at the Heartland Institute, who's been working on tax policy with us for a couple decades now, is going to be talking about Donald Trump's potential tax plan next week. So very timely. We planned that out months ago, and here it is. We're talking about the tax plan of Trump right as it's coming along. So you're going to want to be here for that as well. Thank you all so much for coming out tonight. Be safe getting home. Thank you.